Hello friend, this question is from test series number 1, the subject of network theory and the topic name is network solution methodology. The problem is a 1 marks problem. In the problem we have one circuit which contain a one current source of value 3 ampere, a voltage source of value 6 volt and a switch which named S. So question says that the switch S is initially open and the circuit has reached a steady state. On that condition, at time t is equal to 0 you have closed the switch. At time t is equal to 0 the switch was closed, and now find out the current I just after the changes happen, just after the switch is closed. So you need to find the time current I at t is equal to 0 plus. So you know that the circuit contains only resistive element, and resistor allows the sudden change of current. Resistor allows the sudden change of current and voltages. So what does it mean? It means that resistor does not show any transient effect. So it doesn't really matters what is the condition before the switch is open. As far as you are concerned, for you this is the circuit, a close connected circuit, because we don't have any transient effect here. So it's a simple problem of superposition theorem. Let's calculate the current I using superposition theorem, using one energy source at a time, because we know that what superposition theorem says. That superposition theorem says that if my circuit is linear and bidirectional, so I can use superposition theorem, and superposition theorem says that if you have more than one energy sources, so you can use one energy source at a time. You replace all other voltage sources with open circuit, all other voltage sources with short circuit, and all other current sources with open circuit. Okay, so we have a linear network, right? Because the resistor is also only there, and it's a bidirectional also, so no issue, we can apply superposition theorem here. Let's consider one energy source at a time. Let's consider first current source. So my effective circuit will be, we have a current source of 3 ampere, then we have a resistor of 2 ohm, then we have another resistor of 1 ohm, and this voltage source is shorted. So if this voltage source is shorted, so this 2 ohm resistor will going to be short, right? Because this is shorted by the voltage source. So my effective circuit will be this much, one 3 ampere current source with two parallel paths, in which I am interested in the current across 2 ohms. So my current I, which is in this case is I dash, I should name it as a I dash. So this I dash will be 3 into total current of the other branch upon total resistance, which is 1 ampere. So using the current source, I have calculated the one component of the current I, which is 1 ampere. Now in the second case, now let us consider voltage source and replace the current source with open circuit. So my effective circuit will have a 1 ohm resistor, we have a 2 ohm resistor, we have a voltage source, and then we have another 2 ohm resistor. So effectively we have a network like this, in which we have a 6 volt voltage source, and I have a 2 resistor, 2 ohms, and this 1 ohm and 2 ohm in series, that is 3 ohms. Right, this is my network, and I'm interested in the current across 2 ohm, which is the current across 3 ohm in this case, which will be I double dash. Okay, and here's one important point to be noticed, that which is a noticeable point, which is the current I. Direction of the current I is from, let's say, top to bottom, or just name this node as a B, A and B, so A to B. Okay, and my first component I dash is also directing in the same direction of the I dash, is also same, that is from A to B, right? So this A dash is also from A to B, and similarly my I double dash is also moving from nothing else, also moving from the A to B, right? So all the three components have a same direction. This is good. So my I double dash will be voltage across 3 ohm is 6 volt, 6 upon 3, that is 2 ampere, you know that in series current remains same, so current across 1 ohm, 2 ohm, and this combined current 3 ohm will be the same, and the direction is also from A to B. So if the directions of the current is same, then current is going to add. So my total current I is the addition of two components, that is I dash and I double dash, which is 1 ampere plus 2 ampere, which is 3 ampere. So the current I is 3 ampere, right? So the value of current I is 3 ampere. It's a simple superposition theorem based problem. Okay, theorems is a very important topic in the GATE point of view. It's a part of the first unit, network solution methodologies. Superposition theorem, network, Norton's, maximum power, these four theorems are very important. Every year you will get one problem of either of it. Okay, one, or at least you can expect at least two problem from this. Okay, one or so earlier when we used to have a common data and a linked data problems, then it was in every paper we used to have a one common data or a linked data problem from this topic. So you can understand the weightage and the importance of this unit. So please consider this topic very important. Thank you.